Hello everyone, I am Manav, and in this video we are gonna discuss about atom. So let's begin with the topic that is atom. First of all, I will give you some of the examples that relates with this topic, that is atom. You know that what is matter? Anything that occupies some space and has mass, matter present in it. If I talk about chair on which I'm sitting, is it matter? Is it? Yes, that is matter. Why it is matter? First of all, this thing, particular chair has what? It has mass. There is something that is present in it from which it is made of plastic. It is occupying space. Yes. There is a space. There is some area that it is covering. Is it right? Absolutely. Now this particular chair is also occupying some space, and there is also some mass. It also has some mass. It has weight or mass. So if I want to tell you that what is the difference between my mass and weight? Very easy. It is very easy. First thing that you must remember about mass, that it is a type of force. What? It is a type of force. Okay. So if it is a force, so what would be its SI unit? Standard unit. Standard international unit. Each and every force has its own unit, but just like weight or any force, push and pull has the SI unit, that is Newton. So the SI unit of particular my weight is Newton. If I talk about mass, the matter that is present in this chair, in your mobile, in these clothes, is what? Nothing but matter, mass. What is the SI unit of mass? What is the SI unit of mass? SI unit of mass is kg, kilogram. Second thing, weight is a variable. Weight is a variable. What do you mean? You know the meaning of variable? You know the meaning of variable? What? Meaning of variable is nothing but the any value that will never remain same. If it is 10, it will never remain 10 from place to place. It always changes We have already studied this in algebra. What? Algebraic expressions. Algebra. It is not algebra. It is algebra. We have studied that thing also in particular that topic. What is a variable? What is a constant? Now, if we will also use this word constant. Now, if I move to the point of mass, I think first I should tell you what is the meaning of constant. What do you mean by constant? Constant is that value that will never change. It will always remain as that it is. It will always remain as that as it is. Yeah, absolutely. For example, 10. 10 will remain 10 if I'll go to moon, if I'll go to anywhere. It will always remain as 10. Is it right? Absolutely. Now, my weight is a variable. Yes, my weight is a variable. Mean it changes. You know the formula of weight. Weight is equal to m multiplied by small g. What is small g? Acceleration due to gravity. Multiply by what? Mass. The matter that is present in this chair, the matter that is present in that particular object, in that particular material of which you are finding the weight. This particular mass and weight is, I think, in my gravitational chapter. Yeah, in gravitational chapter. And what will be the value of G? On Earth, the value of the G is 9.8 meter per second. Acceleration due to gravity. For your simplification, you sometimes takes it 10 meter per second, but never take it 10 meter per second while measuring the weight. Always take 9.8 meter per second. That is my exact value. But that is my exact value. Okay. Now, where were we? Yes, mass. You will take it 9.8 meter per second. That is too much important. If you will go to moon, the gravitational acceleration due to gravity is 6 times lesser than on Earth. So, if you find out your weight on the moon, it will 6 times lesser than on the Earth. Now, from this statement, this is fully proved that my weight is a variable. It changes with place to place. Mass, weight, both things are done. Absolutely. You want an example? Let's take it. You want to measure weight of an object whose Mass is 2 kg. I'm thinking simple. So I don't have any pen or paper that can do calculation. I'll multiply it with 9.8 if I am measuring it on Earth. Suppose I am measuring it on Earth. Okay. Now, if you, me, everyone are measuring it on Earth, what will it be? 9.8 multiplied by 2 or 2 multiplied by 9.8. If I'll multiply, it would be 19.6 Newton. It is weight. Divided by 6. Why? Because now I am measuring it on moon. Simple. 19.6 divided by 9. Yes, divided by 6 would be near about 3.2, and after that some value would be there. I'm not doing that particular full calculation here. That's why. Now I usually went to another topic, but now we will only concentrate on atoms. So this main object is made up of small units. What? Small units. Small units known as atom. Now I am going to tell you a story from where these atoms produced in our history. A story starts from where? Our story starts from where? From none of other country but from India. Yes. There was a scientist, I cannot remember that name. Chandra Patel, like this, there was a name of a scientist who was saying in past, who said that he will find the smallest unit from which this matter made. And in his particular this voyage, in this particular journey, he took a slab of, no, the rate of that particular thing is too much. But he took AU. What he took? He took AU in chemistry language. But in real or in English, say it gold. AU. Symbol is AU. Okay. AU, he took AU mean gold. At that time, I think gold was too much easy to buy, or it was not too much particular. What we can say that thing. It was not too much worthy. There was no too much worth of that gold at that time, so that's why he took gold. But now I think nobody will take gold as in an experiment. as it has touched the rays of the gold has touched the sky. ठीक है ना? फिर भी he took a piece of gold. I don't know how much big it was, but he took. He started beating. At that time he started beating it. It was going into very small units. But he was not able to find the unit that he was trying. The aim was of finding the smallest unit, but he cannot. So after some time, he left this world. After that, to I think Greece, not Greece. There is a language in which atom is known as atomos. I can't remember that language also. There were two the scientists from that particular country, and they said that the smallest unit is this world will be known as atomos. They gave a name that was atomos. Its real mean was smallest unit. What its real mean was smallest unit. So chalo theek hai. Okay. This was just a story. But what are atom? What is atom? Atom is the smallest unit from which this matter made up of. John Dalton told many of, he also gave theory on atom, and that improved the study of matter at that time in 1808. He gave a particular this particular theory. Okay, so he said that atom cannot be divided into more parts, but there are also subatomic particles of atom. You know that how small atoms are? Atomic radius of particular atom is different. What atomic radius? How much bigger they are? And there was a thing that I would like to tell to you. I think that was I started forgetting many things. Yeah. Anybody has seen atom? From John Dalton to those Greek. I got that word, Greek language. There is a Greek word that is atomos, that mean the smallest unit. Those Greek scientists. Anybody has seen? No. Nobody has seen till the date how the atom is loved. Because they are too much small. You know that the size of one hydrogen atom, I think it is 10 raised to the power minus 11 or I think minus 9. Too much small. Nanometer. That is too much small unit. You can't see that from a powerful microscope. from a powerful microscope. Yes, you cannot see. So, if I move to other things that are how to write an atom, that is XAZ. 3 alphabet. XAZ. What? XAZ. X is the symbol of atom. Now, after some researches, John Dalton gave also some symbols, but they were too much weird. So we stopped the use of them and started other symbols that were given by other scientists. They were too much simpler to write and speak. So if I tell you those particular symbols that were for Mercury, a circle and some design like this. Yes, Mercury and design like this. Like this. I mean semicircles. And for oxygen only just circle. For gold, G and circle. For iron, circle and I. So scientists said, they gave their opinion and they said that these symbols takes too much time to write. So they give their own symbols. Aluminium, Al, gold, Au, silver, Ag, iron, Fe, mercury, Hg, helium, H, hydrogen, I think it is also H. Oh, helium is He. Yeah, He. And if I talk about hydrogen, H. Carbon, C. Lead, Pb. Potassium, K. Sodium, Na. This is the language of chemistry. Please remember this. Now, there are 3 laws of chemical combination. 3 laws of chemical combination. First, law of conservation. Law of conservation of mass. What this law states? This law states that the mass of the total mass of the reactant before a chemical reaction is equal to the product of that particular chemical reaction. What do you mean by this? You have a reactant. Let's suppose you want to make carbon dioxide. Carbon dioxide is my product. The mass of that product will be always equal to the product mass of my total sum of my reactants. What are reactants? The things that participate in a chemical reaction, and after that they become product. These are what? First law. Second law states that it is also known as law of direct proportion. It states that your proportion of elements, this element is this and this element will be this in a chemical combination, in a chemical reaction, will remain same. And it does not depend on from where you have taken in that particular element. Yes. Third law. It was given by John Dalton. I know this thing. This is law of multiple proportion. While two or more element chemically combine and form a compound, the ratio of the mixture is in a simple ratio, simple form. So I hope, friend, you understand our today's topic. Our topic is completed. I'll meet you in my next video. Until then, stay connected with me. This line I always speak in the last of my video. Thank you. Thank you.